Welcome to Kaiju Mathematics. Today I will be evaluating a limit as x approaches a value of a function that needs to be factored. If you like this content and you need more math and CalcuDoku in your life, please consider subscribing, and thank you for watching. I have f of x equals x squared minus 16 over x minus 4. So in this scenario, you want to be aware of the domain, meaning what can the function not equal. So in this one, what we want to notice here is this x minus 4 in the denominator. So we want to see what can x not equal, because we cannot have 0 in the denominator. So x, if we add 4 over, x cannot equal 4. So meaning at 4, we have something happening. We have a hole, we have an asymptote, we have a jump. Something's happening at 4 where 4 does not exist in the domain. So it's going to be a graph, and we're going to have some sort of gap at 4. The graph will do something, approach 4, but not cross through the x value of 4. So over here. I was looking at negative 4, but over here. So x equal to 4. So now we're just asked the question, well, what is happening as the limit as x approaches 4? So what we want to do is we want to take the limit as x approaches 4 from the left, and we want to take the limit as x approaches 4 from the right. So I'm just trying to prepare you for the fact that some questions will just ask limit as x approaches 4, where you have to understand what we got to take from left and right. Because if you just evaluate at 4, look what happens. So I'm going to plug in 4 into here. So we're going to have 4 squared minus 16 over 4 minus 4. We get 4 squared is 16. 16 minus 16 over 4 minus 4. 16 minus 16 is 0. 4 minus 4 is 0. We get 0 over 0. So we can't have that. No good. So that's why we have to look at what's happening from the left and from the right to get an understanding of what is happening as we approach 4. So I'm going to do this with that numerical approach, creating a table, and then I want to show you another strategy of doing this that you will probably want to make sure you're doing moving forward, because you might notice something here right off the bat, but I just want to show you something real quick with approaching 4 from the left and 4 from the right. So if we were to do that same approach, we're looking at 4 from the left, so I could take 3.9, plug it into the function, so I'd have 3.9 squared minus 16 over 3.9 minus 4. And that's going to be 7.9, and then 3.99. So 3.99 squared minus 16 over 3.99 minus 4. And you get 7.99. And then 3.999 is going to give you 7.999. So you can start to make the conclusion, all right, it's going to 8. It's approaching 8 from the left. And we check the right. So as we approach 4 from the right, we can do 4.1, plug it in. So 4.1 squared minus 16 divided by 4.1 minus 4. That's 8.1. And then we would do 4.01. 4.01 squared minus 16 divided by 4.01 minus 4. 8.01. And then we get a little closer, and we get 8.001. So you can start to see it's approaching 8. So when asked the question, when x approaches 4, from the left, it's equal to 8. From the right, it's equal to 8. So therefore, as x approaches 4, it is equal to 8. So that's the long-winded approach. That's the long, not doing anything other than evaluating numerically, plugging in values from the right, plugging in values from the left, seeing what happens. Now, another thing that we want to make sure we're probably doing at the beginning of this, moving forward, is if we can factor, we should factor, because you'll see something that happens here. So factoring, I have x squared minus 16 over x minus 4. X squared minus 16 is a difference of 2 squares. So I'm going to factor that to x minus 4 and x plus 4 let me move that over a little bit. So x cannot equal 4, as we established. So this is x minus 4 and x plus 4 over x minus 4. So what happens then, as you'll notice, I have a factor of x minus 4 on top. I have a factor on x minus 4 on bottom. So those are going to cancel out. So all I'm left with then is just f of x is equal to x plus 4. And you can do the same thing from the left, from the right, and you're going to get the same exact answer. You're going to get, as the limit as x approaches 4, you get 8. But I want to show you now, since we have this function, look how easy this is to graph now. This is just a function of x plus 4, so y-intercept of 4. And remember, our domain, x cannot equal 4. The domain is all reals besides 4. So it cannot equal 4. So when I graph this, this is going to be a hole at 4. So I'm going to go up 1, over 1, up 1, over 1, up 1, over 1. Then at 4, I have a hole. And then it exists everywhere else. So it's going to exist everywhere but at 4. It's going this way, and then it's going to go on this way. So as I approaches from the left, I approach 8, right here. From the left, approaching 8. From the right, approaching 8. And that's okay. It approaches 8 from the left and from the right, so therefore the limit as x approaches 4 is 8, but it doesn't exist. There is no function value there. We does not exist at 4. It just approaches 4, or approaches 8 from the left and from the right, but it does not exist at x equal to 4. The limit exists, but the function value does not exist. And we're going to look at some more examples of that too.